This is the video for section 3.2 on the properties of parallel lines. So remember, parallel lines are coplanar lines, they have to lie in the same plane, that do not intersect. And a transversal is a line that intersects two or more other lines. So in the picture I've drawn here, line K and line N are parallel, and line T is the transversal because it intersects both of those lines. It cuts through them. Transversal is a line that cuts through two or more lines. We have a number of angles that are formed when that transversal cuts through those parallel lines. We have 8 angles, and we have different names for some of those angles. Angle 3 and angle 5 are called same side interior angles, and so are angle 4 and angle 6. They are on the interior of the parallel lines, and they're on the same side of the transversal. So angle 3 and angle 5 are same side interior angles. Angle 4 and angle 6 are same side interior angles. Angle 1 and angle 5 are called corresponding angles. They are in the same relative position on each parallel line. They are above the parallel. They are above each of their lines and to the left of the transversal. So angle 2 and angle 6 are corresponding angles. Angle 3 and angle 7 are corresponding angles. Angle 4 and angle 8 are corresponding angles. And then we also had alternate interior angles. Angles that are on the inside of the parallel lines. They are interior, but they are on alternate sides of the transversal. Those would be angle 3 and angle 6. That's a pair of alternate interior angles. And then angle 4 and angle 5 are another pair of alternate interior angles. So that's all terminology that we learned in section 3.1. So now in this section we're going to learn how to use parallel lines and learn their properties. We begin with this postulate. Remember, a postulate is something that we assume to be true without proof. If we assume this postulate to be true, then we'll be able to prove several other theorems based off of this postulate. And this postulate is reasonably true. It does not seem unreasonable to assume that this is true. If we have two parallel lines that are cut by a transversal, as I've drawn there, then corresponding angles are congruent. The way we represent that two lines are parallel are we put these little markings that I'll highlight in green here, these arrows going in the same direction, to indicate that those two lines are parallel. Notice that I have stopped putting arrows on the ends of my lines. That way I'm not confused between those arrows and the arrows that are indicating they're parallel. So from now on, I won't be putting arrows on the ends of my lines, and I won't expect you to put arrows on the ends of your lines unless I tell you otherwise. Okay? But these two arrows mean that those two lines are parallel. And you see my transversal, and I've labeled all 8 of my angles, 1, 2, 3, 4, 5, 6, 7, and 8. So this postulate says corresponding angles are congruent. So one set of corresponding angles we have is angle 1 and angle 5. Those correspond because they're in the same relative position. They are above their line and to the left of the transversal. So this postulate says angle 1 is congruent to angle 5. Okay, which angle corresponds with angle 2? Well, that would be angle 6. So angle 2 is congruent to angle 6. Okay, which angle corresponds with angle 3? That would be angle 7, the one below the line and to the left of the transversal. So angle 3 is congruent to angle 7. And then angle 4 is congruent to angle 8. Okay, corresponding angles are congruent when we have parallel lines. What I've written in orange here, that I'll underline, that is a shortened way to write that postulate if we end up needing to use it in a proof later. Rather than writing out what the whole postulate says, we can just write it in that shortened form. Those two slanted lines mean parallel lines. That arrow means implies, so parallel lines imply corresponding angles are congruent. Okay, that's a shortened form of what that postulate says, so that when we're writing it as a reason and a proof, we don't need to write out every word of the postulate. Okay, now that we have that postulate, we can use that to prove these theorems. I won't actually prove them in the video. The proofs are in your book if you want to see them. And we might look at them in class. but I'm just going to introduce you to what these theorems are doing. First theorem says if two parallel lines are cut by a transversal, so like I've drawn here, two parallel lines, I can mark that they're parallel with these arrows. Two parallel lines are cut by a transversal, then we're going to find another set of angles that have to be congruent. We had corresponding angles before. Now we'll see that it looks like angle 3 and angle 6 are congruent. And angle 4 and angle 5 look congruent. Those pairs of angles are called alternate interior angles. They are on the interior of the parallel lines and on alternate sides of the transversal. So this theorem says if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Alternate interior angles are congruent. Okay? So that means in this picture, angle 3 is congruent to angle 6, and angle 4 is congruent to angle 5. The shortened way to write this theorem would be to write parallel lines, it's two slanted lines, imply alternate, which I'll write as ALT period, interior, INT period, angles are congruent. Parallel lines imply that alternate interior angles are congruent. Okay? Our next theorem is very, very similar. It starts out the same way. If two parallel lines are cut by a transversal, let's see if we can find in our picture another set of angles that are congruent. Let's say we know corresponding angles are congruent, and we know alternate interior angles are congruent. What can we say about angle 3 and angle 5? They certainly aren't congruent, but they actually add up to 180. So they are supplementary. So if two parallel lines are cut by a transversal, then same side interior angles are supplementary. Same side interior angles are supplementary. So in this picture that would mean angle 3 plus angle 5 equals 180 degrees. We also have another pair of same side interior angles. They're on the other side of the transversal. Angle 4 plus angle 6 would equal 180 degrees. Okay? Same side interior angles are supplementary. Shortened way to write this theorem would be to say parallel lines imply, I'm going to write out same side, and then INT for interior angles are supplementary. Okay, so to review, so far we have parallel lines give us corresponding angles congruent to each other. Parallel lines give us alternate interior angles congruent to each other. And parallel lines give us same side interior angles that are supplementary to each other. Okay, one last theorem. If a transversal is perpendicular to one of two parallel lines, so in the picture I've drawn, we have these two parallel lines, and then this transversal, which we can call line T, and it's perpendicular to the top line, as I've indicated with that red box. So angle 1 is a right angle. Then it certainly looks like it's perpendicular to the bottom line. Why would that be true? We know angle 1 and angle 2 are congruent. Why? Because they're corresponding angles, right? So if angle 1 is perpendicular, angle 2 also has to be. If angle 1 is a right angle, angle 2 also has to be a right angle. So if it's perpendicular to the top line, it also has to be perpendicular to the bottom line. Because angle 1 and angle 2 are corresponding angles, and our postulate told us corresponding angles were congruent. They're corresponding angles because they're in the same relative position, above the line and to the left of the transversal. Okay? So this tells us if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line as well. It's perpendicular to the other line as well. Okay? Those are our theorems. That's it. Okay? To review, if two parallel lines are cut by a transversal, corresponding angles are congruent. If two parallel lines are cut by a transversal, alternate interior angles are congruent. And if two parallel lines are cut by a transversal, same side interior angles are supplementary. And finally, if a transversal is perpendicular to one of two parallel lines, it's also perpendicular to the other one. Alright, here are your immediate practice problems. We have this picture, two parallel lines, and a transversal that cuts through them. I've labeled all the angles, 1, 2, 3, 4, 5, 6, 7, and 8. Number 1, name all of the angles that are congruent to angle 1. And number 2, if angle 5 is 60 degrees, find the measure of angle 6, the measure of angle 4, the measure of angle 1, and the measure of angle 8. Use the postulate and theorems from this section. And that is the end of section 3.2.